So this is about environmental sustainability of digital education. And to be frank, there is not a lot of information about this to be found in the literature. So, but I will show you what I have found. First, this is just a how should I say? A word of caution. There is a report from the International Energy Agency, which I found quite useful. It was about streaming video and the carbon dioxide emissions related to that. But in this report, they also talk about the reliability of sources. So in this beginning here, they show the carbon dioxide emissions associated with half an hour show on the Netflix. And then you can see there are different bars here. And at the bottom, you have two green bars, one representing the energy or the carbon dioxide emissions related to boiling a kettle of water. And the second one is driving 5 kilometers with your car. And then there are four dark blue bars here. And those are different sources which have been referred to in the daily journals or magazines. So you have seen this data has been referred to in everyday media. But they are not quite correct. So the light blue estimates here are related to the calculations done by International Energy Agency in their report. And you can see that there is a very large difference. And first, we could see that there was some data which were completely wrong. So this Shift project, or in their original version, claimed that watching half an hour show on Netflix would require almost twice as much, or would give rise to about twice as much carbon dioxide emissions as running 5 kilometers with your car, which sounds unreasonable. And when they updated the information, they ended up somewhere here. So it's 1/8 or so of the original. But also these values are highly questioned then by the report from the IEA. So also the IEA have done different assumptions here and come to different conclusions. But it's in the range of the carbon dioxide emissions of boiling a kettle of water, as you can see. And then if we look at the top here, there are three bars with different nationalities: Australia, United Kingdom, and France. And of course, this is related to the difference here is that the electricity is generated in different ways. In France, most of the electricity is generated from nuclear, so very little carbon dioxide emissions. And in Australia, they're more dependent on coal, and in the United Kingdom, it's obviously somewhere in between. So, of course, we should be aware that the source of the electricity, or where we assume that the source of the electricity is, will have a large impact on the results. So when we look at different comparisons, we should always ask ourselves, where do they assume that the electricity come from? Is it an world average carbon emission value, or is it a European average, or is it for a specific country, France or Sweden or England or Australia? So that makes a big difference. Yeah. So that was one part of this study, but they also have in this study what they call an interactive CO2 emission calculator. And let me see if I can switch to that page. Here you can see some bars again. And now we're looking at the breakdown of carbon dioxide emissions from 1 hour of streaming. And we are assuming that we have the world average of the carbon dioxide emissions per kilowatt hour of electricity generated. And the two bottom bars here are just for reference. The bottom one is for boiling a kettle, just like before, 34 grams, assuming the world average carbon dioxide emissions electricity. And then we have a weighted average. So this is for different modes of communicating to get this 1 hour of streaming. And then this top bar here is if we assume that we are looking at this streaming through a smartphone with a moderate resolution or standard resolution of the screen, and we're using 4G to communicate. So in this case, the release of carbon dioxide is about 3 grams for this case. And then we can switch here. We can go for a different device, a different resolution, or a different way of communicating, or we could change the part of the world where we do this, where we're looking at this, we do the streaming. So in this case, we assume that we have a laptop instead of a smartphone that we had in the first case. So a laptop standard resolution, we're assuming that we use the Wi-Fi. And now we are assuming that we are close to the router, so that a little bit less energy is used for the communication with the router. So in this case, you can see that the green part of the bar here which is the device that has increased a lot. So the laptop uses much more energy than the mobile phone, which was here in the first slide I showed you. So from 3 gram to 12 gram, mainly dependent on the increase or the difference between the laptop and the mobile phone. And next we could change to using the laptop still, but now using ultra high definition video. And this would increase the amount of energy used in the data center, and thereby also the carbon dioxide emissions from the data center. So now the total is 18 grams, and the main difference from the previous stage here, as you can see, is that the ultra high definition video requires more energy and thereby more CO2 emissions in the data center. So what would be next? We can now change, so we have the laptop still, ultra high definition video, but we assume that we sit in the other end of the house, so we just barely have contact with the router. And this means that the data transmission energy for data transmission is increasing quite a lot. So compared to this previous case where we are having low, or we're sitting close to the router, Wi-Fi is low, and in this case, Wi-Fi is high. So there's a large increase in the amount of energy or CO2 emissions related to the data transmission. So now the total is 25 grams here. And next, we use a television set, a 50-inch LED TV, still using ultra high definition video. And we have the TV connected to the router, which is a distance away. So we have high Wi-Fi energy use, you could say. And now suddenly we have to change the scale here. So because the TV requires a lot of more energy than the laptop, which we looked at before. So therefore, the total energy use now is 71 grams, or the total CO2 emissions is 71 grams for 1 hour of streaming. So now it's totally dominating. The TV is totally dominating compared to the other parts. And now these two graphs, they look very similar if I flip back and forth, as you can see, but the number is changing a lot. So in the case we looked at before, it's 71 gram, but now it's suddenly 3 grams. And this is because now we're looking at Sweden instead. So in this calculator, I assume that the we are in Sweden, and the electricity mix is the Swedish electricity mix, which is mainly hydro, nuclear, and wind power, and very little fossil fuels. So now the energy or CO2 emissions has decreased down to 3 grams, even though the energy use is the same. So this once again shows that the original of the electricity is extremely important. And then, of course, it's important to know which countries have low and high CO2 emissions related to their electricity production. And this, I just added here a map showing the share of electricity from low carbon sources in 2022. So the darker here, the more energy from low carbon sources, which could be nuclear, as in the case of France, or it could be hydro and some nuclear, as in Sweden, or mainly hydro, as in Norway. So depending on where you are, you have different ways of producing the electricity, and thereby also different CO2 emissions related to the electricity.